So as per the syllabus of VTU, we're having the Euler's equation of motion and Bernoulli's equation of motion. These two are important definitions as for the exam point of view. First, I'll start with the Euler's equation of motion. So this is equation of motion in which gravity force and pressure force are taken into consideration. So we are going to consider only gravity force and pressure force into account for deriving the Euler's equation of motion. So it is derived by considering the fluid element motion along with the streamline. So along the streamline we are considering the fluid motion. So first of all, consider the streamline in which fluid flowing takes place in S direction. So this is the S direction. In that particular S direction, so we are going to consider the streamline in which the fluid is flowing. Consider a cylindrical element of cross section dA and a length ds that is shown in the figure. So dA is the cross sectional area of the element and length is ds. So the force acting on the cylindrical elements are, so what are the forces acting on the cylindrical elements are? Just look at the diagram. You are having one PdA force and one more P plus 2P by dou S into ds into dA, that is in the opposite direction of PdA, and it is having self weight. So the pressure force PdA in the direction of the fluid flow, that is along the direction of the S direction. So that is one force. So second force, the pressure force P plus dou P by dou S into ds into dA, which is opposite to the pressure force PdA, or which is opposite to the direction of the flow. So this is the second force. Third force, the weight of the element rho g dA into ds. So this is the third force. So totally there are three forces which are acting on the cylindrical elements of the fluid flow. Let theta is the angle between the direction of flow and action of weight of the fluid element. So here we have taken the angle theta, that is the angle between the direction of the flow and the action of weight of the fluid element. If you consider the resultant force which acts on the fluid element in the direction of the S direction or streamline, so that is equal to the mass of the fluid element into acceleration in S direction. The resultant force on the fluid element in the direction of S equal to mass of the fluid element into acceleration in the S direction. So we have taken the resultant force. We have already taken the three forces. The sum of all forces should be taken as a resultant forces, but the PdA should be acting in the towards the direction of the flow, so that should be taken as a positive value, and P plus dou P by dou S in ds in dA, that is acting in the opposite direction of the flow, means it should be taken as a negative value. And sulfate, the sulfate is acting towards the downward direction, means this is also along the direction of this P plus dou P by dou S in ds into dA. That's why both should be taken as a negative value. Yes, PdA is a positive, minus P plus dou P by dou S into ds into dA, that is in the opposite direction of the direction of flow, means negative. Sulfate is also downward direction, negative. That should be equal to mass of the fluid element. What is the mass? Equal to rho into dA into rho into dA into ds into acceleration A. So this should be treated as equation number 1. So if we simplify this particular equation number 1, so we'll get, before that, so we'll define the acceleration. The acceleration is what? So dv by dt means that is the differentiation of velocity with respect to time. So velocity is the differentiation of distance with respect to time. So that is a function of t and s, where s is the length and t is the time. So a equal to dv by dt. If you take the chain rule, so to indicate the acceleration value, so a equal to dou e by dou s into ds by dt. So ds it cancelled, will dou e by dou t. So we ultimately will get a equal to dou e by dou s into ds by dt. ds means differentiation of distance and length with respect to time, that gives you velocity. So in place of ds by dt will substitute velocity plus dou e by dou t. So if the flow is steady flow, so already we have explained these things in the fluid kinematic chapter. The steady flow is a type of flow in which the fluid characteristic like pressure, volume, velocity, density all should be constant with respect to time. So that's why the dou e by dou t equal to 0. So substitute this steady condition in the acceleration value, a equal to dou e by dou s into v. So we got the value for acceleration now. That substitute that particular acceleration value in the equation number 1. So p dA minus P into dA. So simplify this this pressure force. So P into dA. So the minus is there. So minus P dA. Next minus into plus minus dou P by dou S into ds into dA minus weight term as it is. But you are having a theta cos theta angle, because the angle theta is the angle between that direction of the flow and the weight of the element. That's why it is cos theta. Next, so mass of the actual element is rho into d into ds into acceleration. Acceleration means v into dou e by dou s. So if you simplify this one, p dA get cancelled. So in whole equation, if you divided by rho into dA into ds, rho into dA into ds, this will get dou p by rho into rho p by rho into ds minus here in this equation rho into dA ds will left with only g value, g cos theta equal to, here rho into dA ds get cancelled, will left with v dou v by ds. If we take all the minus term that side, it will become 0. So dou p by rho into ds plus g cos theta plus v into dou v by dou s equal to 0. So from this cylindrical element, so we are having a trigonometric ratio as cos theta, because in this particular equation we are having a trigonometric ratio function as cos theta. If we simplify, if we take the value for cos theta from this particular triangle, the cos theta equal to dz by ds. So substitute dz by ds equal to cos theta in the above equation, we'll get 1 by rho equal into dou p by dou s plus g into dz by ds plus v into dou e by dou s. So here so in particular equation ds is a common term, so take that ds as a common and take that side, it will become 0. We left with dou p by rho plus g dz plus v dv equal to 0. So this is what our Euler's equation. So 100% this will ask for the 10 marks in the examination. So this is what Euler's equation of motion.